Today, otherwise, today we are discussing about calibration of Venturiflume experiment. So Venturiflume, it is also a measuring instruments where we will be using to measure the discharge which is flowing in any pipeline. Normally, what happens is whenever we are seeing a pipeline, if you wanted to measure what is the discharge flowing through the pipe, we can put this Venturiflume, where Venturiflume is a setup which will be like having an inlet which is of size same of the pipe, and there will be throat where it is a reduced diameter, and after that the water will be exiting out at a downstream with the same diameter of the pipe. So the major advantage of this Venturiflume is we can calculate, or we can just calculate the different discharges, and also it is used to get the CD value, that is the coefficient of discharge for the experiment. So the major of the experiment is to calculate the calibration of Venturiflume using the setup. Okay, and first normally what happens is the flow which will be taking from the left will be considered as the inlet. Inlet will be having a width of inlet we are taking as B1, and the width at the throat we are considering as B2, and after that the water will be exiting out at the downstream in the same diameter. Now the readings what we will be taking while doing the experiment is first at the upstream. At the upstream is at the section 1, that is at this point of the inlet point. So initially we will be taking the initial reading which will be kept same for all the different sets, and final reading will be changing whenever we change the discharge. So difference of initial and final will be H1. Similarly on the downstream or at the throat section there will be another manometer connected. There will be two manometers actually connected at the inlet and throat. So those two manometers will be connected using the U-tube. So this particular connection will be reading as H1 on the left side and H2 on the right side. Okay, and after that, similarly on the downstream side at the throat section we will be taking initial reading, final reading, and then difference at H2. So the total difference in the head of water in this U-tube, total difference in the head of the U-tube will be given as HF. That's your due to Venturiflume. So that is difference of H1, H2 considered as HF. And after that the water which will be passing out from the downstream will be collected in a collecting tank. So which will be taking as a time for 10 cm rise of water collected in the collecting tank as t seconds. So using these observations we will be calculating the actual discharge, theoretical discharge, and the coefficient of discharge. Now the initial observations what we will be taking is firstly the width of channel at the upstream or at the inlet part, that is B1, from this value B1 it is equal to 25 cm, and the width of channel at the throat part, that is at the reduced diameter, it is B2 is 9 cm, and after that the rise of water in the collecting tank will be considered as I told you, it is 10 cm capital H, and the area of the collecting tank which we are using is 80 cm by 80 cm, so it is area will be 6400 cm square, and the formula to be used for actual discharge is AH by T, where A is area of collecting tank, H is the rise of 10 cm, and T is time fill, that is the time used to fill that 10 cm rise. And theoretical discharge formula is A1 A2 into root of 2GH by under root of A1 square minus A2 square, where A1 and A2 are, A1 is the area at section 1, that is at the inlet, and A2 is the area of throat in the Venturiflume. So the formula for them, A1 is B1 into H1, where B1 is width at inlet, and H1 is the head of water that is coming at the upstream part. And similarly A2 is B2 into H2, where B2 is the width at the throat, and H2 is this downstream reading taken at the throat part. So that will be A1, A2. Using these two values we will be substituting in theoretical equation of discharge, and after calculating these two actual and theoretical discharge we will be calculating the coefficient as ratio of the discharges. Okay, that is what about the experiment.
Experiment is Venturiflume, and this is the machinery for Venturiflume. Here you can see this is the upstream and this is the downstream. You can see from inside it is a slant. Here upstream is upwards and downstream is a little down, which is passing through Venturiflume. This is a Venturiflume. The diameter here is 25 centimeters and the diameter here is 9 centimeters.
Movable trolley for taking.
This is a hook gauge movable trolley where you will be taking the upstream reading and then by rolling it downwards you will see the downstream reading. So now the water is allowed to flow through the, you can see the water flowing down, and now it is adjusted. This is the initial reading of the upstream. This is the reading of the upstream. Yeah, this is the initial reading of the upstream.
Same trolley can move. Same trolley can move.
And now the trolley is moved towards the downstream, and this is the final reading in the downstream.
Same water collection.
Then that water flows to the collecting tank, whose area is 18 to 80,
And close the valve.
and this is the scale where you will be taking 10 centimeter rise, that is capital H. So you have to close the valve. After that you will be seeing the water rise level here. So we'll take it as 20 centimeters, and once it reaches the 20 centimeters you will
Now
start
start the
the
watch.
stopwatch,
10 centimeter rise of
and
water.
you will see, you will wait for till the water rises for 10 centimeter, that is capital H. This is the reading of the collecting tank, the water rise in the collecting tank. And once it reaches 30
Stopwatch.
centimeters, we will stop the stopwatch. This is nothing but time taken in T seconds for the rise of 10 centimeters in the water tank or the collecting tank.
Collecting.
So now you have the values of, to find out Q actual, that is capital A is equals to the area of the water tank, that is 18 to 86,400, and the small t is the time taken in the stopwatch, and capital H is the scale reading, that is 10 centimeters.